burn and set my hair on fire. But what we're going to look into now is what we call the flame test. Some experiments call this one the firework colors. So let's look into that a bit. So fireworks are made out of hot embers of metals, and it turns out that many of the metals on the periodic table have a characteristic color when they burn. Okay, and this color happens from extreme temperatures where they are hot enough to excite the electrons. Now, every atom is going to be different. Therefore, the number of electrons on their outer shell is going to be different. And also, distances from one electron shell to the other will be a little bit different as well. This is why we get such a variety of colors. When you excite them, the electrons jump up to an excited state where they're further away from the nucleus than they want to be under those the energy that you've given it, and then it wants to release that energy, so relax, will come back down to the ground state, or close as they can be to the nucleus. And as they jump down, every jump back towards the center is going to release pockets of energy, okay? Quanta of energy, and it's usually expressed as light, frequencies of light. So if we got low frequencies, we should see colors like red. If we see high frequencies, we should see colors like purple. But let's look at the main constituents. Most metals will actually make a white color. So let me just cut off the lamp here. And we're now going to look at magnesium. Now, this one here is incredibly bright, so my assistant will just make sure that he's not looking directly. He can look to one side. And then once it catches, we have a very bright white flame. And this is what you would normally see as they arc through the sky. That's probably going to be magnesium. Zirconium also makes really bright white colors. My assistant is going to go for a different substance. So this time we're not going for the raw metal itself. We've actually got the metal in solution, sodium chloride. Now, sodium will still make an influence on the color of this flame here. So if my assistant puts it in, we get a very orange-yellow flame, and it's very bright. And this color is the same color you would see on motorways, like highways, where they have very cheap sodium vapor lamps. So that gives it that yellow color. If you have this kind of lamps on your street side and you're trying to figure out the difference between the recycling bin and the general waste bin, you may not be able to tell them apart because that yellow is so intense. Yeah, potassium chloride. This one's very difficult to see. It's going to give us a pale purple. We call it a lilac color. It looks like we're not going to have much luck here. We're getting mostly the color of the wood burning in this situation here. So we might try a different chemical. Now, what he's putting through the flame is actually a matchstick. This matchstick has been soaking overnight in these different chemicals. And the chemicals are all the same, so they're all some form of chloride compound. The only thing that we've got different between them all is the metal. So if we see a difference in color, it's going to be due to the metal and not because of the chloride. Barium. So barium's going to give us a very orangey yellow as well. Let's go for strontium next. Now, strontium is going to probably look more familiar to us. A lot of the fireworks will have the big red as part of their explosive, plumes. Red is most likely to be a result of strontium because strontium gives a beautiful, dark, deep red color. We're getting a little bit of wood burning, but it's unavoidable. But the majority of this color, I think you can see, is that red flame. There it goes. We've lit the toothpick on fire. Copper chloride. So this is copper metal, mainly at work here, giving us our color of our flame. Giving us a beautiful green, Harry Potter green color. And now it looks like we're just burning at this point here. So those are some of the chemicals that are famous for giving you colors of the fireworks. When they explode, they burn with little bits of these trace elements, and that's what gives us our different colors. If you want to learn more as to this whole electrons being excited and relaxing to create these different colors, I do have a video about this where I'm